Excellent. Okay, so my name is Natasha Sangha. I'm a student in the MRC doctoral training program in precision medicine. And I'm going to talk a little bit today about exploring relationships between seasonality, circadian rhythmicity, and mood disorders using machine learning. So these are some preliminary findings that we have so far. So far, research has shown that actually circadian rest activity rhythms do change for people that have a mood disorder versus people that don't have a mood disorder. And we've seen that with objective measures of rest activity rhythms, so say wrist tracker data. We've seen it with subjective measures as well, so say people that fill out questionnaires. And we've seen it for different varieties of the different mood disorders that you can see on screen. So one thing we want to really understand is whether these rest activity rhythms are different for these different mood disorders. And a key part of this might be seasonality. So some aspects of these mood disorders are more prone to seasonality than others. So mania, research has shown that there are spikes in mania in spring, and as you might expect, sometimes spikes in depression in winter as well. So we're keen to understand the relationship there. So to do this and to explore this, we use the UK Biobank, which is a sort of large biobank of data, many participants that volunteered to take part in a bunch of tests and questionnaires. And as part of this, a subset of them took part in a specific mental health questionnaire, but also everybody participated in a touchscreen questionnaire, which contained a variety of different questions about mental health as well. So between these two questionnaires, we're able to group people into probable mood disorder category. It also contains demographic and lifestyle data, so information about sex, age, BMI, deprivation, alcohol intake, and smoking status as well. And then for a subset of participants, they actually wore an accelerometer, so a wrist tracker for 7 days. And from this, we can get an objective measure of what their sleep and activity rhythms are like. On top of that, there are also a couple of questions within UK Biobank to do with sleep and activity, which gives us a bit of a subjective measure. So questions about your sort of usual sleep duration, whether you find it difficult to wake up, and your chronotype, so whether you're a sort of morning person or an evening person. And we were then able to link this data through to Met Office data as well. So within UK Biobank, you can get coordinates of sort of roughly where somebody lives within, I think it's a kilometre. And within the Met Office data, you can get sort of 1 kilometre by 1 kilometre grids. And within each of those grids, you can get sort of monthly averages of the hours of sun, the number of days over a month that you have ground frost, or the number of millimetres of rain on a daily basis. And the idea is that these are all probably confounding variables for somebody's activity as well. If anybody else is like me, I don't particularly like going out when it rains. So as expected, there might be a relationship there. So once we removed anybody that had missing data, we wound up with a full data set of 39,687 participants. And this was quite control heavy. So we took a random sample of 10,000 control participants and set them aside and used their circadian, so their wrist tracker data. We standardized that and applied that same standardization to the rest of the data. So we're essentially comparing everybody to quite a large chunk of control participants. And for the rest of the data, we split that into 6 equal groups. And these groups were stratified for not just mood disorder, but also sort of key confounders such as age, sex, deprivation, the season of actigraph wear, BMI, smoking status, and alcohol intake. And then the idea by splitting these into the sort of 5 different training groups is we could use cross-validation to create an algorithm that's more generalizable, and then have a separate test data set as well. So at the bottom are just some graphs that kind of show the distribution for some of these variables. And the first key step was really to look at a model that would just compare healthy controls to people having any mood disorder whatsoever. So we did this using an extreme gradient boosting model, which is just a tree-based model. So it's very good at allowing for quite complex interactions between different variables and incorporating a lot of different variables. And extreme gradient boosting itself is actually quite a fast implementation and usually quite accurate as well. So it tends to be quite a good one. And when we do this and we break down those results by the underlying mood disorder group, We see a couple of sort of interesting things. So on the left-hand side here is a model that isn't so great. You can see the accuracy is quite low for the mood disorder groups. And on the right-hand side is a model that's doing quite a bit better. We've added some new variables and all the accuracies are a bit higher. But what we see across all of them is that depending on your mood disorder group, the accuracy tends to change, which suggests that one model isn't really good enough for capturing all of the differences within these groups, and that actually they might be a bit different between them. The other interesting thing about this is you might expect that the differences in accuracies might be due to some groups being larger than others, but actually the bipolar depression group, which is this pink line in both of them, is the highest, and it's actually the second smallest group. So it's not due to sort of just like having larger influence from certain groups. And the other final thing that's really interesting about this is, as you've probably noticed, the purple lines at the bottom, which represent the unipolar mania accuracies, tend to fluctuate with seasons. So you see that on the left-hand side, there's quite a big dip in accuracy in spring, and on the right-hand side, a dip in winter. And you also kind of see a bit of that with the bipolar disorder group as well. So that suggests that maybe these groups that have a sort of mania component can sort of be quite down to season as well. So the next step from here was to then look at each mood disorder group specifically. And so we compared them to a sort of matched group of healthy controls. And when we do that, on the left-hand side, as you see, the accuracies go up, as you would expect. We've got mood disorder group specific models now, and so much more targeted. But with the unipolar mania group, which is this purple line, you still see that actually there's a big dip in accuracy for spring and winter. So there's quite a difference in how their rest activity rhythms change over the different seasons. And on the right-hand side here, what you can see is for each model, basically the amount of influence that each sort of category of variables has. And what's interesting is for the unipolar mania group, the seasonal and weather variables actually have a much bigger influence than any of the other groups. And also they're quite dependent on the objective sleep and activity variables. Whereas for the other groups, you can see that there's a bit more of a split between your objective and your subjective sleep and activity, and definitely way less dependence on the seasonal and weather variables. So this kind of suggests that maybe unipolar mania is actually quite different from the others. So I guess the key takeaway things from this talk are that unipolar mania, the models for those are driven by the weather and seasonal variables and objective rest activity variables more so than they are for other mood disorders. And particularly for unipolar mania, you see these big fluctuations in seasonal accuracy as well, but we do see that slightly with the bipolar disorder group as well. And then the model accuracy is continuously highest for our recurrent major depression and bipolar disorder groups, which suggests that maybe they are quite different from healthy controls in terms of rest activity rhythms. And the next step is probably kind of the obvious one. Can we actually use these differences to differentiate between these different groups? And that's what we're going to look at next. So we'll take each of the mood disorder groups and compare them not just to healthy controls, but also to the other mood disorders and see whether we can get high enough accuracy there. So thank you very much.